Welcome to all of you SJEC e-learning YouTube classes. Student, please subscribe the channel to update about your syllabus.
Welcome student. Now today we continue the chapter Law of Motion and today's topic is Newton's third law of motion. Okay. Newton's first law tells us that to bring a change in the state of rest or in state of motion of an object, a force is needed. That is, a force produces a change in velocity of the object. Newton's second law tells us the magnitude of acceleration produced by the force when applied on the object. These two laws do not explain how does the force act on the object. This question is answered by the Newton's third law, which is stated as follows. According to Newton's third law of motion, to every action there is always an equal opposite reaction. Okay? For an example, consider a book lying on a table. The weight of book acts vertically downward, but the book does not move downward. It implies that the resultant force on the book is zero, which is possible only if the table exerts on an equal upward force on the book equal to the weight of the book. This force on the book balances the weight of the book. That's right. The weight of book acting on the table downward is the force of action and force exerted by table on the book upward is the force of reaction. So, the Newton's third law of motion states in an interaction of two bodies A and B, the magnitude of reaction is equal in magnitude to the action, but they are in direction opposite to each other. That is called the Newton's third law of motion.
Examples of Newton's third law of motion. The first example, the motion of boat in water. To move a boat ahead in water, the boatman pushes the water backward with his oar, and the water exerts an equal and opposite force of reaction in the forward direction on the boat, due to which the boat moves ahead. Okay. So the second example, a book on a table. When a book is placed on a tabletop, the book exerts a force equal to its weight, that is action, on the table in direction downward, and the table balances it by an equal force called the reaction force acting upward on the book. Okay, these are the action and reaction forces. And the next example, firing a bullet from a gun. When a man fires a bullet from a gun, a force is exerted on the bullet, that is action, and the gun experiences an equal recoil, that is reaction. So, this is the Newton's third law of example.
Okay, the next topic is gravitation. The universal law of gravitation, each mass particle of the universe attracts the other mass particle. The force of attraction between the two particles because of their masses is called gravitational force of attraction. For the magnitude of this force, Sir Isaac Newton gave a law known as Newton's law of gravitation. According to the Newton, the force of attraction acting between the two particles is directly proportional to the product of their masses and inverse proportional to the square of the distance between them. Let that is the mass m1, okay, and that is the mass m2. That is force F1, F2, and the distance between them, that is R. Okay. Then F is directly proportional to the product of mass m1 m2, and F is inverse proportional to the distance of the masses, the square of distance mass. So F is directly proportional to m1 m2 upon r square. If you remove the proportional sign, a constant came g, m1 m2 upon r square. where G is a constant of proportionality which is known as gravitational constant. The value of G remains same at all places and it is independent of the nature of particles, temperature, medium. Therefore, it is a universal constant and is known as universal gravitational constant. That's okay. The value of G is equal to 6.67 into 10 raised to the power minus 11 and the unit is Newton meter square per kg square. That's okay. Now the importance of law of gravitation. Newton used this law to explain the motion of planet around the sun, the motion of moon around the earth and motion of freely falling body. Now the force due to gravity. Force due to gravity. Okay? According to the law of gravitation, the earth attracts each object around it towards its center. The force with which the earth attracts a body is called force due to gravity on the body, which can be taken to act vertically downward at the center of gravity of the body. In vertical motion near the earth's surface for height much smaller than the radius of earth, the force of gravity on the body is assumed to be same throughout. That's okay. If the force due to gravity of a body of mass m kept on the surface of earth of mass m and radius is capital R is equal to the force of attraction, then F is equal to G mass of earth, mass of object upon radius of earth. That's okay. If we put the value m mass of earth is equal to 5.96 into 10 raised to the power 24 kg. Easy. Radius is 6.37 into 10 to the power 6 meter and the mass of object is 1 kg. Now F is equal to G 6.67 into 10 raised to the power minus 11 into 5.96 into 10 raised to the power 24 into 1 upon 6.37 into 10 raised to the power 6 ka square. Now we solve it, then F is equal to 9.8 Newton. So Earth attract a body of mass 1 kg by a force of 9.8 Newton its center. That's right. Relationship between G and G. Let G be the acceleration due to gravity at a planet of mass capital M and radius capital R. By Newton's law of motion, the force due to gravity on a body of mass M on its surface will be F is equal to mass into acceleration due to gravity, that is G. And Newton's gravitational law, F is equal to G mmr square. Then in equation 1 and 2 equate it, then mg is equal to G mm upon r square, cancel, G is equal to G mr square. Okay, that is the relationship between the G and capital G.
We have studied one-dimensional motion, the motion of a freely falling body from a height or the motion of a body thrown vertically upward from the surface of earth is the one-dimensional motion under gravity. The acceleration of a vertical falling body is G plus and that of a body going vertically down upward is G minus. If a body falls from rest freely from a height h under gravity, then u is equal to 0 and acceleration a is replaced by g, that is the acceleration due to gravity. Then equation of motions are v is equal to gt, h is equal to half gt square, and v square is equal to 2gh. But if the initial velocity of fall of the body is u, then equation of motion are v is equal to u plus gt, h is equal to ut plus half gt square, and v square is equal to u square plus 2gh. If a body is thrown vertically up with an initial velocity u to a height h, there will be retardation, means g minus. Then equation of motions are v is equal to u minus gt, h is equal to ut minus half gt square, and v square is equal to u square minus 2gh. At the highest point of reach, final velocity is 0. So the maximum height reached is h is equal to u square upon 2g. From the equation, v square is equal to u square minus 2gh. And the time taken by the body to rise to the highest point, t is equal to u upon g. From the equation, v is equal to u minus gt. The same will be the time it take to come back to the initial point after reaching the highest point. So the total time of journey t dash is equal to 2t is equal to 2u upon g, and the total distance travelled by the body h dash is equal to u square upon g, that is equal to 2h also. So what is the mass and weight? Mass. The mass of a body is the quantity of matter it contains. The mass is a scalar quantity. Its SI unit is kilogram. The symbol is kg. It is constant for a given body at rest and does not change by changing the place of the body. It is an intrinsic property of the body. It is measured by a physical balance because the value of g is same on both the pans. The mass of a body increases with its velocity, but this change is only with the velocity of the body. V becomes more than 10 raised to the power 6 meter per second, reaches close to the speed of light. This is 3 into 10 ki power 8 meter per second. So for a body moving with velocity less than 10 raised to the power 6 meter per second, its mass is taken to be constant. What is weight? The weight of a body is the force with which the earth attracts it. In other words, weight of a body is the force of gravity on it. The weight is a vector quantity. Its direction is downwards towards the center of earth. The unit of weight. The SI unit of weight is Newton and the CGS unit is dyne, where 1 Newton is equal to 10 raised to the power 5 dyne. Relationship between weight and mass. The weight of a body is related to its mass. Weight is equal to mass into acceleration due to gravity, means W is equal to m into g. So the value of g varies from place to place. The weight of a given body also varies from place to place. The gravitational unit of weight in MKS system is kilogram force, means kgf, and in series system in gram force, means gf, where 1 kgf is equal to 9.8 Newton and 1 gf is equal to 980 dyne. Obviously, a body of mass mkg will weight mkgf. The weight of a body can be measured by a spring balance directly in Newton and also by physical balance in kgf. What is the comparison of mass and weight? In mass, it is measure of the quantity of matter contained in the body at rest. But in weight, it is the force with which the earth attracts the body. Mass, it is a scalar quantity. But in weight, it is a vector quantity. Mass, the SI unit is kg. And in weight, its SI unit is Newton, which is denoted by capital N. In mass, it is measured by physical balance or beam balance. In weight, it is measured by spring balance, which is calibrated to read in Newton. Mass, it is constant for a body and does not change with the change in place. But weight, it is not constant for a body but varies from place to place due to change in the value of g. Okay. So, the gravitational unit of force. In MKS system, the gravitational unit of force is kilogram force, means kgf. 1 kgf is the force due to gravity on a mass of 1 kg. 1 kgf is equal to force due to gravity on a mass of 1 kg is equal to mass of 1 kg into acceleration due to gravity, means g Newton. Since average value of g is 9.8 meter per second square, so 1 kgf is equal to 9.8 Newton. In CGS system, the gravitational unit of force is gram force, gf. 1 gram force is the force due to gravity on a mass of 1 g. 1 gf is equal to 1 gram into acceleration due to gravity, so is equal to g dyne. The average value of g is 980 centimeter per second square. So 1 gf is equal to 980 dyne. Further, 1 kgf is equal to 1000 gf. That's okay. Some important points of our chapter, laws of motion. In this chapter, we study what is force. A force is that physical causes which changes either the size or the shape or the state of rest or of motion of the body. We study that kind of forces. There are two kinds of force, contact force and non-contact force. What is the contact force? The force which are applied on bodies by making a physical contact, that is called the contact force. There are some contact forces, that is frictional force, normal reaction force, tension force, force exerted by a spring and force exerted during collision. Second one is non-contact force. The forces experienced by bodies even without being physically touched are called the non-contact forces. Some non-contact forces are gravitational force, electrostatic force and magnetic force. That's okay. So here we study the Newton's first law of motion and inertia. What is the Newton's first law of motion? According to Newton's first law of motion, if a body is in a state of rest, it will remain in the state of rest, and if it is in the state of motion, it will remain moving in the same direction with the same speed unless an external force is applied on it. What is the inertia? The property of an object by virtue of which it neither changes its state nor it tends to change the state is called inertia. There are two types of inertia. What inertia of rest and inertia of motion. Okay. The Newton's second law of motion. What is the Newton's second law of motion? According to the Newton's second law of motion, the rate of change of momentum of a body is directly proportional to the force applied on it, and the change in momentum takes place in the direction in which the force is applied. That is called the Newton's second law of motion. Newton's third law of motion. What is the Newton's third law of motion? According to the Newton's third law of motion, to every action there is always an equal and opposite reaction. That is called the Newton's third law of motion. So, some example of the Newton's first law of motion is when a train suddenly starts moving forward, the passengers standing in the compartment tend to fall backward. The other one, when a hanging carpet is beaten with a stick, the dust particles start falling out it. On striking the coin at the bottom of a pile of carom coin with the striker, lowest coin only move away while the rest of the pile remain intact. A cyclist riding along a level road does not come to rest immediately after he stops pedaling. Passenger jumps out of a moving train, he falls down. When a running car stops suddenly, the passenger tends to lean forward. An athlete often runs before taking a long jump. That all are the example of Newton's first law of motion. Some example of Newton's second law of motion. While catching a ball, the cricketer withdraw his hand along with the ball. Athletes often land on sand after taking a high jump. And when the glass vessel fall on a hard floor, they break, but they do not break when they fall on carpet. Why? When a glass vessel fall from the height on a hard floor, it come to rest almost uh, large force on the vessel and it break. But if it fall on a carpet, the time duration in which the vessel come to rest increase, and so the carpet exert a less force on the vessel and it does not break. Some example of Newton's third law of motion. Pushing a wall, rocket motion, a book on a table, that all are the example of Newton's third law of motion. For an example, that the rocket motion. In a rocket, fuel is burnt inside the rocket and the burnt gases at high pressure and high temperature are expelled out of the rocket through a nozzle. Thus, the rocket exerts a force on gas to expel them through a nozzle backward. The outgoing gases exert an equal and opposite force on the rocket, that is a reaction force, due to which it moves in the forward direction. So, what is the gravitation? Gravitation is the universal law of gravitation. Each mass particle of the universe attract the other mass particle. The mass of attraction between the two particles because of their masses is called the gravitational force of attraction. Sir Isaac Newton gave a law. This law is called the Newton's law of gravitation. According to the Newton, the force of attraction acting between the two particles directly proportional to the product of their masses and inverse proportional to the square of the distance between them. This force acts along the line joining the two particles. In starting video, we studied that. F is equal to G m1 m2 upon r square. The value of G is 6.67 into 10 raised to the power minus 11 Newton meter square per kg square. Okay. So, some important note to the gravitational force is it is always attractive in nature and is directly proportional to the product of the masses, is inverse proportional to the square of separation between them. That is, it obeys the inverse square law. Thus, by doubling the separation between the two masses, the force of attraction between them is reduced to 1/4. Is significant between the heavenly bodies, but is significant between ordinary bodies because of small magnitude of G. Okay. Importance of the law of gravitation. Newton used this law to explain the motion of planet around the sun, the motion of the moon around the earth, and the motion of freely falling body. So, what is the acceleration due to gravity? Galileo was the first scientist to study the motion of different bodies under the force of attraction of earth. From his experiment, Galileo found that if bodies of different masses and sizes are simultaneously made to fall in volume from the same height, they all reach the earth's surface and with same velocity. Thus, all bodies travel the same distance in the same interval of time. Moreover, he found that the velocity of a freely falling body does not remain constant, but it increases at a constant rate. The motion of a freely falling body is a uniformly accelerated motion. This acceleration is same for all bodies. In other words, the acceleration of a freely falling body does not depend on the mass of the body, its size and its shape. This acceleration is called the acceleration due to gravity. That's okay. And If we take the mass of Earth m 5.96 into 10 raised to the power 24 kg and the radius of Earth is 6.37 into 10 raised to the power 6 meter, the acceleration due to gravity at a place on the surface of Earth comes out to be g is equal to 6.67 to 10 raised to the power minus 11 into 5.96 into 10 raised to the power 24 upon 6.37 to 10 raised to the power 6 whole square. So it comes 9.8. So the value is 9.8 meter per second square. On the surface of moon, the mass of moon is 7.36 into 10 raised to the power 22 kg and the radius is 1.75 into 10 raised to the power 6 meter. The acceleration due to gravity at the surface of moon is 1.6 meter per second square. That is 1/6 of Earth gravity. That's okay.